welcome back. We will continue with our discussion on second level packaging as part of our electronic packaging and manufacturing course. In the last two lectures, we had started talking about motherboards, okay? And in the last lecture, we were looking at motherboard materials, where we said that if you take a typical motherboard or circuit board, printed wiring board, these are all being used interchangeably, synonymously, right. So, there typically the two major components or constituents of a circuit board is number one, a glass woven cloth in a polymer binding matrix, and number two, copper, okay. Because this copper, that is the main ingredient for having these wiring traces that go through the different layers in a circuit board. Okay. So, today we will continue with our discussions on circuit board materials, and today we will take off from, if you recall, we were discussing the laminate materials before, right, and we talked about the different types of motherboards, the nomenclature or the laminate materials, the nomenclature of laminate materials, FR4, FR5 and so on and so forth. So, today we will focus on the, we will start with focus on the copper part, okay, which is the second major ingredient. Okay. So, that is what we see here. The concepts that are going to be covered today is circuit board materials, which is, and we are going to focus on copper, and then we are going to go to the fabrication part, where we will see that how the different layers of these circuit boards are fabricated and then assembled on top of each other. Okay. So, let us go over here. What is the copper that is being used in a circuit board? Okay. So, the copper that we need should be in the form of a foil, because if you look at the wiring traces that go inside a circuit board, these are really very thin. If you talk about, I mean, they go anywhere in the range of, let us say, 15 microns to about 75 microns and so on. Okay. So, really thin copper. Okay. So, where are we going to get these traces from? We will get these from a foil which is of that thickness. Okay. So, that is what we are looking at. The copper foil can come in two forms, and we are going to look at that. The first one is called an electrodeposited copper foil, where you will see that this foil is deposited in the form because of an electrolytic process, and the second one is by rolling. Okay. And we will see both of these. But before going to that process, let us also look at a certain standard nomenclature in the electronics industry, and which is actually borrowed from the roofing industry. The thickness of the copper foil is measured in ounce per feet squared. So, it is ounce per feet squared, all right. So, 1 ounce per feet squared corresponds to 1.35 mils. Mil is milli inch, and therefore, it is about 35 microns, right. So, that is what is used. So, if somebody tells you that the copper that was used, the copper foil that was used for fabrication of this 4-layer motherboard was 2 ounce per feet squared. So, then if you look over here, 2 ounce per feet square actually means the thickness of the foil was 70 microns. Okay. Similarly, 1/3 ounce per feet squared or 0.33 ounce per feet squared, that is 12 microns, okay, 0.45 milli inches. 1 mil is 25 microns. Okay. Just because 1 inch is 25 mm, therefore, 1 milli inch will be 25 microns. Okay. That is the way to remember, all right. And so, I am showing here that the nomenclature in terms of copper thickness, or nomenclature for copper thickness, is in terms of ounce per feet squared, and corresponding thicknesses both in mils and microns are shown on this slide. Okay. So, with that, let us move on to the next slide. Now, this one is a very basic unit that goes to make a motherboard. Okay. So, this is called a copper clad laminate. See, we talked about the laminate in the last lecture. What is the laminate? that is this glass glass fibers or glass cloth inside this polymer matrix, right, crisscrossed, and that is the laminate. And then we talked about copper in the last slide. So, right now a copper clad laminate is what? That is as shown in the picture, it is a laminate with a copper sheet on either side. So, copper clad laminate or CCL, you can look at it, is made up of a fully cured epoxy resin fiber core. Okay. So, that is the laminate we talked about, sandwiched between two layers of copper cladding. Okay. The copper cladding will eventually become two inner layers and the laminate will act as a dielectric spacing between the two layers. Okay. So, eventually this copper cladding is going to become an inner layer. So, now it is continuous copper. Then what we will do is we will remove the copper where it is not needed and retain only the copper which will correspond to now these wiring traces. Okay. So, therefore, a printed wiring board fabrication, if you look at it, this CCL becomes one of the building blocks. It is a base material, a base assembly on which we are going to build layer by layer. Okay. So, once again CCL or copper clad laminate is a laminate layer with two copper layers or two sheets of copper on the two sides. Okay. That is CCL. Okay. All right. So, we are talking about copper foil and we said that there are two different ways by which this copper foil can be made. The first is called electrodeposition, which is shown over here. So, what is this? In electrodeposition, if the copper is electrodeposited, the copper foil is there. First you have what is, it is a rotating drum made of titanium, okay, which is dipped in an electrolyte, and then there are two electrodes. Okay. So, what happens is the copper foil is first deposited on this rotating drum, okay, and then what happens is then you have a spindle and then the sheet is as is shown here from the drum on which it is deposited, it comes out and then it is rolled in the in this form. Okay. So, now what happens is, how is this copper deposited? Because of the electrolytic process. Okay. Now, therefore, what happens is as it gets deposited on the drum, then the side that gets deposited on the drum surface is a smooth side, okay, and the side that is exposed to this electrolyte becomes slightly rough. So, if you look at the surface finish, one will be a shiny smooth finish, the other will be a little rough or matte finish. Okay. And the matte finish actually helps also later in terms of adhesion. Okay. But the surface treatments enhance this adhesion between the copper and the dielectric interlayer during copper clad lamination process. So, if you go back over here, then this copper sheet that we saw in this electrodeposited this copper sheet that is, or copper foil that is resulting from this electrodeposition process is the one that goes to form these layers on the two sides of the laminate and gives you the CCL or the copper clad laminate. Okay. So, we also do some surface treatment, not just for adhesion, but also to prevent or at least slow down, if not prevent, at least to minimize the surface oxidation. Okay. So, on the bottom side you see a picture where one can see the copper foil and you see that the bottom side is very shiny, whereas the top side is matte, because the bottom side, the shiny side, was actually attached to the rotating titanium drum, whereas the other side, which is the matte side, was exposed to the electrolyte. Okay. All right. So, this was one process of getting a copper foil. What is the other one? This was an electrodeposition process. The other one is a mechanical process of the rolling. Okay. So, what we do is you take a thicker sheet of copper and successively cold roll the copper. So, in the rolling mill you see these are these rotating rolls as you see, and as a copper billet as it is called, or a slab, as it goes through these rolls it is kind of thinned down. So, if you go to a mechanical rolling mill, any steel industry and all, you will be able to see rolling mill is a very is one of the very important shops, where from the rolling mill the metal comes out in the form of sheets. So, in this case here as you can see that this one as it is rolled, it finally gives you the very thin sheet or foil in this case. Okay. So, the surface smoothness or surface roughness depends really on the rolling mill, okay, on the rolls that is present. So, this is not going to be a heavy duty rolling mill that you see in a steel plant, let us say. Okay. This will be more delicate and more sophisticated. The surface treatment to form a good adhesive bond with the laminate. Okay. So, again like before, we will do a surface treatment both to prevent oxidation as well as to form a good adhesive bond. Okay. And finally, the rolled copper offers high ductility. A rolled copper offers a higher ductility compared to electrodeposited copper, and therefore, you see this more flexible PCBs these days. You know, you have these bands where you need flexible motherboards. It is not rigid anymore. Okay. So, that is a different type, different kind, but there if you have these wiring traces, that copper you need it to be more ductile, and that is what it is. Okay. So, therefore, in such scenarios or such applications, it is the rolled copper foil that is used. Clear? All right. So, we talked about two methods of getting this copper foil. The one is through electrodeposition and the other is through cold rolling, as we see here. And then once we have the laminate and we have the copper foil, we can have the copper clad laminate, a picture of which we saw 2 slides back, and which we said was a base material for the fabrication of the motherboard or for the fabrication of the circuit board. Okay. So, remember when we saw this first one, this CCL copper clad laminate, what did we say? We said that these copper foils that is deposited on either side will eventually become or will eventually be the basis for having these wiring traces. We said that from this copper we are going to retain that part which is used for having these wiring traces and remove the rest. Okay. So, how are we going to do that? That is the next question. So, here we are going to spend a few minutes on this slide and then again recap what we call the lithography process. Okay. So, what is the first step? The first step is the first building block is the copper clad laminate. We saw that it is one laminate and then 2 copper foils on both sides. Next thing what we do is we will put a photoresist on both sides of the copper. So, both on the top. So, we will cover the copper foil with this photoresist. Okay. Then what we will do is we will have this what is called the mask. Okay. So, the mask, what is it? It is going to have cutouts for for those areas or portions where we want to have the wiring trace, and it will, and the rest of it will be covered. Okay. So, that is the mask. The mask will expose only that part when put on this photoresist is going to expose only those parts which are eventually going to become wiring traces. Okay. So, then what we do is once this mask is put, then we go through the photolithography process, as a result of which what happens is we are able to remove the we are only able to retain the photoresist at the place where we are going to have the wiring trace and remove the rest of it. Okay. And that is what we are showing here. So, once this is done, then what we are going to do is we are going to etch this remaining copper away. So, look at this fourth figure from the top, and what we are left with is now the laminate and then some portions of this copper foil which was initially, or the copper cladding which was initially attached to the laminate. Okay. The rest of the copper has been removed by etching. We are going to talk about the etching process later. Okay. Actually, both of these processes. Okay. Next, what happens? We will remove this photoresist, and what are we left with? We are left with the laminate and a portion of the copper which is actually a wiring trace. Okay. So, we started with the figure 1, the topmost figure, and we ended up, after a photolithography and etching process, we ended up with a configuration which is shown in the 5th figure from the top. All right. And then what we do is we will do a black oxide coating on this for protection and all. Clear? So, this is how you can see this now eventually forms the inner layer. So, you have a laminate and you have copper traces. Okay. If this was just a 2-layer motherboard, that is it. If it is a 4-layer motherboard, then we have to bring 2 more outer layers on top of it. If it is a 6-layer, there will be more inner layers and then outer layer and so on and so forth. Okay. But this is the inner layer process. Clear? So, now what did we see? We saw that there was this photolithography process. Okay. So, we are going to recap the photolithography process once more. We briefly saw that earlier when we were talking about when we made a diode right in the beginning of the course, we talked about photolithography process. We are going to look at this again now, but with focus on motherboard. So, what is lithography? It is a transfer of image of circuit board features from a photo tool to the copper clad laminate using photoresist techniques. Clear? So, earlier we were removing something else, but now it is about removal of the copper from the copper clad laminate. All right. So, photoresist printing, the photoresist is polymeric coating that is sensitive to light. So, depending on whether it is a positive photoresist or negative photoresist, depending on that, when exposed to light, and typically it is UV light, we are going to either harden the exposed portion or which will be helpful for removal later, or we are going to soften the exposed portion, which is going to be easy for removal later, or we are going to do the opposite, where we are going to soften or we are going to harden the exposed portion, which therefore will be retained and the rest of it can be removed. Okay. So, that is what is shown here, negative working, positive working. All right. So, let us again have a recap of what we did before when we talked about optical photolithography. So, positive photoresist, this is my substrate, and then we have this photoresist layer. It can be PDMS, for example. Then this is the mask. This is a cross section. So, as we can see, the mask, a lot of it is covered and then a part of it is exposed. This is like a cutout in the mask. Okay. Just like our face mask, we have cut out for eyes and nose and mouth. This is a cutout. Next, when we shine UV rays through, then what happens? The UV rays is going to go through the cutout and therefore fall on the photoresist. Okay. But the portions where it is covered with this mask, it is not exposed to the UV light. So, next what happens is it affects some change, probably it changes the property of the photoresist which was subject to UV light and which can be removed easily, or sorry, it changes the properties, okay, which can be removed easily or not, we will see. So, in positive photoresist we remove that, okay, and the remaining part is retained. Clear? In the negative photoresist, what happens is again the same thing, you have the photoresist on top, let us say PDMS, then you bring in the mask, you expose UV light and the property of the photoresist when exposed to UV light changes. This part is till this part is the same, but next what happens is you have some process by which the portion, that part of the photoresist which was not exposed to UV light can be removed, while retaining that portion which was exposed to UV light. Okay. And this is what we saw. If we go back 2 slides, here this is what we saw. The portion which was exposed to the light was retained and the rest of it was removed. Agree? Here also you see that in negative the portion that is exposed is retained, the rest is removed. In positive the portion that is exposed to UV light is removed, the rest is retained. Okay. So, depending on what you want to do, this is the lithography technique, but at least for motherboard which we saw before in the previous slide, what is used is negative photoresist, negative photolithography process. Clear? All right. Okay, I take it back. I think I just by slip of tongue in both positive and negative I said the photoresist, for example, PDMS. Well, no, and PDMS cannot be both positive and negative photoresist, it has to be some other material. Okay. So, optical photolithography, optical lithography or photolithography is done. But next, remember what we said is the remaining copper is etched away. So, chemical process, chemical etching, it is a process that strips the copper cladding away from unprotected regions, that is used. Okay. That is how I am going to retain only the circuit traces or the wiring traces and remove the remaining copper from the copper cladding. Okay. So, that is what the second point says. The copper that remains after etching defines the board features such as circuit traces, solder pads will come later, etc. So, now what are these etching process? There are 2 methods of etching. One is the photoresist coating, the other is a solder plate coating. Okay. So, this is for your information. So, the etching operation, if you look at it, what happens in a circuit board manufacturing plant or manufacturing equipment is that there are automated etching lines, okay, where the circuit board is going, the etchant is sprayed on the board rather at high velocities. Okay. Now, what is the etchant material? The most common is ammonium hydroxide, NH4OH. It is an alkaline, it is an alkali. So, alkaline ammonia it is called some, but it is chemical name ammonium hydroxide, NH4OH. Okay. So, what happens when you etch it? The ammonium ions combine with copper to form cupric ammonium complex ions. So, CuNH34 that hold dissolved copper in solution. Okay. So, that is how the copper is removed. The copper reacts with ammonium hydroxide and is removed. Now, the spent etchant, what is spent etchant? Spent etchant is the etchant once it is sprayed and it has combined with copper, then and what comes out as a product of this chemical reaction, of this chemical etching process, that is the spent etchant that is already used up. Now, what do we do with this? Okay. Now, see, copper is expensive and copper is precious, and you have a lot of copper that you have removed. We started with a complete sheet, and finally, what we retain are some of these traces, majority of it probably is removed, correct. I cannot just waste it. So, therefore, both in terms of material conservation as well as from environmental issues, the spent etchant is reused, or rather is the copper that is in the spent etchant is recycled to recover the copper, which can be further used again. Okay. And after the etching process, the circuit board is washed to remove the etchant and then treated with mild acid to neutralize the surfaces. Remember, the etchant is ammonium hydroxide, it is an alkali. Okay. So, a mild acid is used for washing. First of all, the etchant has to be removed, and then to neutralize the surfaces, the mild acid is being used. Okay. All right. So, this is a diagram, as you can see, it is a conveyor belt, there is an etchant sump. So, what happens is the motherboard goes on the conveyor belt, then this is the etchant is sprayed from the etchant sump on both sides, and then it is rinsed, it is neutralized, again it is rinsed and then dried, and the board comes out. And the spent etchant, as you can see, is removed for recycling, okay, and getting the copper back. Okay. And from the recycling plant, again it is replenished here, and the remaining etchant is replenished over here, and again in pumped and sprayed down, and so on and so forth. Okay. So, with that, what we will do is we will complete today's lecture or this lecture, where what we did here is we looked at, first of all, the copper cladding that goes into a motherboard. Then we started with this elementary block of CCL, copper clad laminate, and from there we looked at the process as to how the rest of the copper is removed and the circuit traces are retained, the wiring traces are retained, right. And while going through that process, we saw that two major fabrication techniques that are used is lithography and followed by etching. So, we went through a revision of these processes. What is lithography, what is etching, and also what is the etching process when you are having these motherboards manufactured. Okay. So, we saw this conveyor belt, how the etchant is sprayed and how the copper is removed, and what is done with the spent etchant, so on and so forth. Okay. All right. So, thank you very much. I hope after this lecture we have a fair idea at least as to what goes into fabrication of a motherboard. Okay. So, when we come back, we will again continue from where we left off or where we are leaving now, and to continue with the topic of motherboard fabrication. Thank you very much.